Hello there, Algebra 2 students, and welcome to a quick video that is going to extend your learning into logarithms. So if you're watching this video right now, the assumption is that, number one, you know how to compose functions, and then you also know that if you are given a function, you know how to find its inverse, how to do the unwrapping. We're going to extend that a little bit. By going to, let's see, oh, you know what? First off, on this, this packet has a lot of log problems. Let's go ahead and work on how to solve these little log problems. This page right here is 3 times, this is said the log of 4 base 2, or the log of base 2 of 4. And that's really asking what power. The answer to a log problem is always an exponent. And what that means is that this here is the base, this 2. So 2 to what power equals 4? 2 raised to what power equals 4? The answer is 2. So the log of 4 base 2 is 2. I'm going to clean it up a little bit here and say that this now, log of 4 base 2 is 2. This is page 3 times 2, or 6. Let's see, what other ones have we put in there? Oh man, I did it already. The log of 81 base 3 means 3 raised to what power yields 81? And 5 raised to what power yields 125? Those little exponent problems, which should kind of be solved in your head. You know 3 times 3 is 9, and 9 times 9 is 81, so that's 3 to the 4th power. And then 5 times 5 is 25, not enough, but one more multiple of 5 gives you 125. The log of 125 base 5 is 3. So that is 7. 4 plus 3 is 7. So that's, sorry you had to wait like a day or two to be perplexed at all these page numbering problems, but now you know how to do them. Okay. Let's go back to, okay, this is going to be, you want, let's see, the log of 8 base 2 means what power does 2 need to be raised to get 8? That is 3. So we're looking at 3 squared, page 9. There's going to be a connection, I promise, soon, but in the first nugget of truth that I'd like you to kind of put down is number 1 nugget. Is that the graph of a function and its inverse are reflections across the line y equals x. What that means is that if you have a function, let's see, oh man, well, how about, let's use one of these. I believe this one is down here. That is y equals 2x plus 5. You double it, the input, and add 5. The inverse, if you were to find it, you switch the x and y, is solve for y. That's equal to 1/2 x minus 5/2. So this one is, you take half of the input and then take away 2.5. Those are inverses of each other. And when you graph them, they will be mirror images across the line y equals x. That's this line right here. This is the line y equals x. It is a fact about functions and their inverses is that they will have a mirror image across this line. Now another nugget of truth here is that, and we'll stay with this example first, if 0, 5 is on this graph, then 5, 0 will be on the graph of its inverse. So here it is generally, and this is nugget number 2, is that if the point x, y is a point on f of x, then y comma x, that's a bad x, come back here, then yx is a point on its inverse. And the inverse we'll call is f inverse of x, f with a little -1. Now remember, that does not mean it's an exponent. I know it's so confusing, the notation. So that's another nugget, just to remember that. And it has to do with the kind of the reversals of the x's and y's and the switching of them. Inputs and outputs now become outputs and inputs. So if x, y is a point on a function, then y comma x is going to be on its inverse. Okay, switching gears now to a little bit of exponents and logarithms. This is the next skill to kind of know, and I'm going to go to page 13. Oh, look, that is nicely not in exponential form, so I think we were on 9. Go to page 13. That's going to be probably the next best place to kind of hover so that we can do a little bit of logs. When it comes to logs, I think, what power? It's answering that question. And the answer to a log problem is an exponent. And here's what I mean. This is read, this number 1, as the log of 136 base 16. And so the answer to that problem is an exponent, and it sometimes helps to kind of reverse and to make it into an exponential problem. Here's the interplay. If y equals b to the x in exponential form, then the log of y base b equals x. The answer to a log problem is an exponent. The base is b, the exponent is x, and it's just written in a different way. It's in the inverse form, log form, or exponent form. So when I do a log problem, I know the answer is going to be an exponent. I sometimes have to just like rethink it in terms of an exponential problem. The log of 136 base 1/6 means 1/6 needs to be raised to some power to yield 136. The answer for that? The answer is 2. Because 1/6 squared is 136. Let's go down on the left side here, like number 3. The log of 1 base 2 means 2 to some power equals 1. That's one of the properties of exponentials. To get the number 1, you raise it to the 0th power. The answer to number 3 is 1. Now, let's see. Okay, I'm going to jump down here to number 8. That's a little bit of an easier problem. The log of 16 base 4 means 4 is raised to some power to yield 16. Answer is 2, because 4 squared is 16. Now on this number 2, log of -125 base 5 means 5 had to be raised to some power to yield -125. That will never happen. It's not possible. Okay, so this particular page this is 13, it also has you practice between rewriting in exponential form. This is just a statement. The log of 1 base 6 is 0. That means 6 to the 0 power equals 1. Number 10, the log of 1/64 base 4 is -3. That's because 4 to the exponent -3 equals 1/64. Now what I'd encourage you to do, if you weren't in class or are missing a little bit, wanted to double check that you've got what you need, is to go to this page, probably 15. This is 3 times 3 to the 5th power is 243, so that is 3 times 5, or 15. So this is page 15, and it gives you some really good problems that are mostly mental math to rewrite each equation in exponential form, to rewrite them in logarithmic form, and then to evaluate, like 125 to what power gives you 5? Okay, may that be a good start for your logarithmic journey, and thanks for tuning in.